Hey guys, Grassman here. Today we're going to do some fun with geometry. So I was having a conversation with someone in the math Discord channel. Math and puzzles, it's called. And we were having a discussion about the angles of a point. Or the degrees of a point. Which I will get to. But first, there were some other things I wanted to show. So, first off, what is a degree? So a degree is just a certain angle. Like, it's always hard to write here. A degree is just a certain angle of whatever. Of two lines, what angle they meet at. So here they meet at a 9-degree angle. So that's a 90-degree angle. If we look at a circle, draw the best circle I can here, the outside of the circle has 360 degrees. There are 360 degrees on the outside of this circle. On the inside of the circle is another matter we'll come back to. And that's also only if you count the entire outside as one surface. So, now let's look at some basic normal shapes. What about the sides of a square? Doesn't have to be a big square, just a square. So what's the combined inner angle of this square? Well, we know this is 90 degrees, and this is 90 degrees, and this is 90 degrees, and this is 90 degrees. Ignore my bad drawing, I just imagine it's a perfect square. What's that? Well, that's 90 degrees times 4, which gives us 360 degrees. Okay, so a square has 360 degrees. What about a triangle? Draw the best triangle I can. There's like a slightly bumpy surface under here, I apologize. Well, a triangle's angles, this would be like, I don't know, angle theta 1, or I don't know, I don't think you're supposed to do the angle when it's theta. Theta is just like a variable for an angle. Theta 2 and theta 3. Basically, theta 1 plus 2 plus 3 will always equal 180 degrees. A triangle has to have 180 degrees. So you notice the difference between a square and a triangle is 180 degrees. 180 is half of 360. So one less point gives you 180 less degrees. And this actually lines up if we go to something that's maybe not just immediately obvious. If we go to a line. That's a really bad line, but pretend it's perfect. What angles do we get? Well, on this end, we know we have 360 degrees on the outside. And because there's only 360 degrees in total, that means the inside, with 360 maximum, and we're subtracting 360 from the outside, we end up with 0 degrees for the inside. And it's the same for the other thing. 360 on the outside, and that means 0 degrees on the inside. Then, 0 degrees plus 0 degrees equals 0 degrees. So a line has 0 combined degrees on the inside. So great, we figured that out. But now, ladies and gentlemen, we have a pattern. We know that a square, see this, has 360 degrees. And a triangle has 180 degrees. And a line has 0 degrees. What's the pattern? 180 degrees. So, if we look at a pentagon should have 540 degrees. And does it? I don't actually know. I should have looked that up ahead of time, but I'm going to leave that to you. It's your homework now. And the interesting thing that comes back to the point of our question, a point, what does a dot have on the inside? Well, if we follow the pattern of the degrees on the inside, a dot losing 180 degrees would have negative 180 degrees. So that's just it. A singular point has negative 180 degrees. And then a line has nothing. A triangle has 180, a square is 360. We can also follow this a bit further back. If we go for nothing, to be clear, nothing, no dot, no line, no nothing, just any blank spot, actually has negative 360 degrees on the inside. There is, on nothing, there is negative full curvature. Or full angle, yeah. What? No. On the inside of nothing, there is negative a full rotation of degrees. If that makes any sense. Then, if we're going back to the outside, which is like what the conversation accidentally ended up becoming yesterday. Let me move this down a bit. Apparently I wasn't writing the top of the page. I might have to move up after this, which is good. Jeez. Hang on. My apologies, we had a minor collapse. What was I going to say? If we look at the outside degrees of something, the outside degrees of a square, well, we know this is 90. So what's 360 minus 90? Should I have done this here? 360 minus 90 is 270. So we know the outside is 270 degrees. So 270 times 4 equals... 270 times 4 would be 1,000, and 20 times 4 is 80, so 1,080. Yeah. 1,080 degrees. So the outside of a square is 1,080 degrees. What about the outside of a triangle? Well, if we do our triangle here, again, very bad triangle. I apologize, there's bumps in the thing. I should like move over slightly so I can avoid the bumps next time. Our triangle, we know the outsides, whatever configuration there's in, because you can have a lot of triangles, the outside of the inside will always have 180. So we can take 360 minus... we don't really need parentheses, but minus 1... wait, we didn't need parentheses anyway. No, wait, 3... Okay, this is a really weird calculation, but technically it's correct. So the inside will always have 180. So we go 360 times 3 should be 900 and 1080. Yeah, it's still 1080 minus 180. So that's going to give us 900. So again, interestingly, it's actually a jump of minus 180 from the square. Let's look at a line. See if we can get our pattern down. So for a line, what we have nothing on the outside, so we only have the inside. We have nothing on the inside, so we only have the outside. The outside is 360 times 2, which would be 720. Oh god, 720. Hey, look, another gap of 180, which means a dot. Again, following our pattern, a dot on the outside. We're going to subtract 180 from this. On the outside, a dot has 720 minus 180. That's 540. To be clear, we have determined a dot on the inside has negative 180 degrees, and on the outside has 540 degrees. And if you subtract the 180 from the 540, you get back to 360. If that maybe somehow makes this make sense. And again, to be clear, nothing then, nothing has outside curvature of 360 degrees. So nothing on the inside has negative 360, and on the outside has 360, which kind of makes sense. Because then when you're combining the outside and inside, you get nothing. Which, logically, is what nothing would be, right? Very interesting. I'm going to move the paper up now. I'm going to pause it for a moment. But there's one other thing I want to show you, which is kind of a proof-ish as to why it's changing by 180. Okay, so you may be thinking, okay, why is it always changing by 180? That just doesn't make any sense. Why is it specifically 180? Why is it not 360 or some other random value, or why doesn't it change? Well, I'll show you with triangles. It's something very interesting, though. If we take a normal triangle, which I can actually draw better because there's no lump on the up here. If we take a normal triangle, we know this thing has 180 degrees, right? Now what happens if we start flattening the triangle? Well, it still has to have 180 degrees. Let's flatten it again. 180 degrees. You see where I'm going with this? What if we now flatten it to be a line? To be clear, where are points on this? Because the points are what actually matter. The points are where the degrees come in. The points are here, here, and here. We have 3 points. This point has 0 degrees, because it's 360 on the outside. Same with this one. 0 plus 0, plus this one here has 180. 0 plus 0 plus 180 equals 180. Can you just about see that? There. 0 plus 0 equals 180. So a line is actually a valid triangle if you have a point in the middle. Because you remember, your basic is extending from this point to this point, and then your two top pieces are going from here to here and here to here. So it's a 180 with 0 and 0, which still equals 180. Now, what happens if we get rid of that middle dot? Well, then we're losing that 180. Then we just have 0 plus 0. So then we would have this. So we have a point here and a point here. 0 plus 0 equals 0. So we have 0 degrees. But wait, that's a line. The lines have 0 degrees. So that's why it changes by 180. Now think about the same thing with the triangle here. If I draw another triangle like this. Now what if I say it's a point up here, over here, over here? You see those 3 points so far? All the corners. And there's a point here. Now how many degrees does this have? Well, we know the triangle, the normal 3 curves, have to add up to 180. And then that one extra dot's going to add 180. So no matter what triangle it is, 180 plus 180, 360. And hey, that lines up the square. Why? Because we can start extending it out. See that? So we've moved that dot further out, and now we move it out now we move the other side further out. And oh hey, what do you know? So now all we've done is we've taken this top bit up here, and we've extended it over to here. Now we've turned our triangle into a square, which we know has 90, 90, 90, 90, which is 360 degrees. So same as the triangle with the extra 180 point is the square. And now you can imagine, let's go backwards all this. The square collapsing into a triangle and then losing that point makes it lose 180. The triangle collapsing to the line and then losing the point makes it lose 180. And then again, you follow the pattern back, the line collapsing makes it lose 180 and somehow it becomes negative. And that's why the inside of nothing is negative 360 and the inside of a dot is negative 180. The outside's another matter. And circles. We're going to talk quickly about circles because that's where the conversation went yesterday and I just want to go over this. It depends how you're looking at it. Remember, if you add more and more sides to a polygon, we can get a pentagon. That's a terrible pentagon. Imagine it's a pentagon. We can get a hexagon. Going over the bump bit again. We can get infinities, and eventually, that was supposed to be a circle. Eventually, it becomes round, right? Infinitely many lines make a circle. So remember we know the inside with every point increases by 180. So a circle actually has on the inside infinite degrees. And on the outside, well, we know that was also increasing. Because the outside does decrease in how much it's worth. Remember, the outsides of the 3 points of the triangle have to be, where's the notes down here? The outsides have to be 900, which means an average of 300 per outside. But the outsides of square are 270. So they're 270 each. So the average decreases. But at a circle, you can see like the outside of where one would end, because it's just becoming more and more like a circle, it does have a limit. And every time you add a point, it does go up by more than it falls down. So a circle's outside actually also has infinite degrees, depending how you look at it. If you're looking at it where the outside is one line, and it just happens to be curved, then yeah, it's 360 degrees. But if you look at it as infinitely many tiny, infinitely small lines, infinitely many, infinitely small lines, it's infinite. Same with the inside, because it depends what you're measuring. If you're measuring the round outside, sure, it's just normal 360 degrees, that's how we measure degrees. But if you're looking at like individual lines, they've got infinite. And going up on the inside, we should get an increase of 180 each time. And on the outside, what was it jumping between? We should also get an increase of 180. It just happens to be slightly higher. It's higher by 1, 2, 3, 4. It's higher by 360 times 2, which is um, 9, no, 6, 720. So the outside will have 720 more degrees than the inside. And I think that covers everything. If we go back down to like here, you can see that well. But we've got a bunch of calculations we did before. We know the outside of the triangle has 900, and of the triangle is 900, and of the square is 180. So the outside will increase by 180, and the insides have 180 and 300. So it'll also increase by 180, but offset. The difference between 180 and 900 is 720. So the outside will always have 720 more degrees than the inside. And we can follow this pattern up and down. So I think that's all. Is that a known geometry thing that the outside will always have 720 more degrees than the inside? I assume it has to be. I can't have just accidentally discovered something. It's gotta be known. I just haven't learned it or something yet. I mean, I guess it's like a random geometry fact, but it could come in helpful. My structure's about to collapse again, but yeah, let me try and zoom out. Let me zoom over everything we got. Ignore the mess. So, all of that is why a dot, a singular point, has negative 180 degrees on the inside, and nothing has negative 360 on the inside. And on the outside, the dot doesn't have 360. On the inside, the dot has... Where was it? On the inside, the dot has 540 degrees. And nothing has positive 360. So, it's very interesting. I don't know what this helps us with in math, but... yeah. Does this accomplish anything for geometry? Is any of this ever used? It's very interesting anyway. So I hope you guys enjoyed. Let me know in the description and the Discord, the Math and Puzzles Discord, if there's like anything I've missed here, or if you would like to debate. Sure, we can argue like, does that pattern really hold true? I believe it does though. So like, you can argue with the patterns, but we do the same thing with like to the power of 1. If where do we have room? A little bit here. If we look at like 1 to the power of 0, well, it equals 1. Why does some number n to the 0 equal 1? Well, because we follow the pattern. It's every time you go down by, the exponent goes down by 1, you divide by that number. Meaning, if the exponent is 0, you're going to divide n by n, which n over n is just 1. So we're following the pattern. We've determined the exponent by a pattern. Therefore, why can't we do the same thing with a dot and a line and nothing? We can also theoretically have a negative point, and it'll have negative degrees? Yeah, so some interesting theoretical stuff that could happen here, but that was the main thing I wanted to show, was that a dot, according to this pattern, which we use the same sort of pattern and thing for exponentials, has negative 180 degrees on the inside. Hope you guys enjoyed. Join the Discord for any like rebukes or rebuttals, and I'll see you next time. Bye, guys.